Welcome to June 29th's LeetCode Challenge, Maximum Consecutive Ones 3. Given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. So we're given an array nums here, and given k equals to 2, if we flip a 0 here and a 0 right here, we get a maximum of 6 consecutive ones in a row. Likewise, example 2, if we can this nums array here, given k equals to 3, we flip this 0, and this 0, we get a maximum of 10 consecutive ones in a row. And we want to return the maximum number of consecutive ones in the array, given the amount of k flips, and we want to optimize this. So the hints basically tell you to do a sliding window type of approach to it, which is a dynamic programming type of approach. So let's go about doing that. So let's give an example here. Where sliding window means that we're going to have 2 pointers at most. So we call this, for instance, a left pointer and a right pointer, right? So we want to move our right pointer along, and if it's equal to 0, we're going to decrement k, so it'll be k decrement by 1, and then we're going to change that to a 1. Alright, and then we keep on moving. Let's keep on moving here. Alright, and we see a 0, boom, turn that into a 1. And then we keep on moving, so we have k, so for instance, k is equal to 2. Now we have k is equal to 1 now. And now we keep on moving the pointer. So we move it one more, and we have r right here, we see another 0. So we make, let's see, oh, no, mine has 2 zeros here. Oh, I have insert on. Alright, we see a, let's see, another 0 over here. So we see another 0 there. And then we're going to make that into a 1, so decrement 1 again, and then we get k equals 0. Because we decremented k twice, and we're going to change this to a 1. So we move our window to, and now we have a, it's a total of 5 ones, because I got ones in a row. So what we want to do is keep on moving it to see if we're able to increase our window size. So we see a 1 here, a 0 here. That means we cannot, let's see, we want to move the left pointer. Let's see, if k is less than 0 now, what we want to do is move the left pointer. So keep on moving that. Oops. Leave R right there. Keep on moving that until k is equal to 0. If the left pointer points at 0, then what we're going to do is that we're going to increment k again, so k plus 1, and then we're going to change the left pointer so that it equals to 1. So let's try it out here. So we're going to define our length nums here. Let's see. Left pointer equals 0. So what do you want to do? So for right in range of length of nums, so we're going to cycle through each right pointer. So if the nums at the left index is equal to 0, we want to decrement k by 1. And then we're going to run in the for loop. So then now we're going to move our right pointer as well. I mean our left pointer. This should be right. So if nums at left is equal to is equal to 0, what do you want to do? We actually want to run this below here. So if k is less than 0, we're going to do, if left pointer is equal to 0, what we're going to do is increment k by 1, and then we're going to increment left by 1 because we have to change the value of the index on left, the pointer for left. And at the end of this, we want to return our maximum consecutive ones in a row. So that'll be right minus left minus plus 1. Alright, let's see if this works. 6, submit. Let's see. Accepted. So this is using a sliding window type of approach to it. Is using like it's considered to be dynamic as well. I mean, you're sliding left pointers and the right pointer, and every time you see that the the index at the right right pointer is equal to 0, you decrement k. Else, if k is less than 0, which means you use up all of our k values to change the number to 1, we're going to search to see if the left index at nums is equal to 0. Then we increment k again. Then we just change the increase the pointer of the left. Then return the maximum consecutive ones. So time complexity would be big O of n, because we cycle through the range of length of nums, so big O of n there. And space complexity would be a big O of constant time, because it's constant time, because these right and left are just pointers, and they don't store any major amount of space, so it's constant space. Alright, that's it. Have a nice day.